Hey, how would you like to create a model of our universe using something as simple as a balloon?
Hi, we're from Fort Washakie School in Fort Washakie, Wyoming. We live on the Wind River Indian Reservation in central Wyoming. We enjoy spending time in the Wind River Mountains, which tower behind our home. Our community consists of many Native American tribes, but most of us are members of the Shoshone tribe. We are proud of our heritage and we celebrate by participating in powwows and traditional ceremonies. We also take pride in our arts and crafts that we have learned from our elders. NASA Connect asks us to help you understand this show's student activity. In this lesson, you'll learn about our expanding universe. You'll also learn how scientists use models to understand observations, and you'll get to plot and analyze data that you'll get from taking distant measurements between objects in your own universe. You see, we'll use an analogy to try to explain a very complex concept.
What's an analogy?
It's simple, really. It's a comparison. For example, sometimes I say my big brother is like a vacuum cleaner when he eats. I use the vacuum cleaner as an analogy to try to explain his eating habits. You're going to use an analogy for the universe to help you understand the idea that it is expanding. When I look out into space, I really don't see anything expanding. It's too big. So we'll use something like the universe to help us understand one of its characteristics that we cannot easily see. A good analogy for the universe expanding would be a loaf of raisin bread baking in the oven. As the loaf expands, the raisins move away from each other. The raisins represent galaxies, and the bread represents space. This is kind of like what happens in the universe. Another analogy for the expansion of the universe is a balloon. Things that exist on the surface of a balloon, for example, these marks, move further apart as the balloon is blown up. In just a minute, we're going to measure the distance between points on a balloon when it is about the size of a grapefruit, then again when it is blown up to about the size of your head. Before we do that, here's something you must understand about an analogy. It's only like what it is compared to in a certain way. The balloon is not the universe, in other words. In fact, the surface of the balloon is only two-dimensional, not three-dimensional like the universe. It would be very hard to measure something inside the balloon because, well, we can't get inside of it. Because we can measure the distance between points on the surface of a balloon, that's what we'll do to verify what Hubble discovered about the universe. He found out the further away a space object is from us, the faster it is moving away from us. Now that you understand about the universe expanding and how we use models and analogies to describe it, you're ready to do the lesson. Separate into groups, then expand your balloon to about the size of a grapefruit. Roll the neck of the balloon, making 3 turns toward the expanded portion. Secure it with a binder clip to keep air from escaping. Mark a point near the balloon's equator. Label the first point as home. Starting from home, measure 10 mm intervals along the balloon's equator and mark 5 points. Label each point starting with the number 1. Measure again the distance to point number 1 from home. Be sure no air has escaped. Record the distance from home to each point. Be careful not to compress or dent the balloon while making the marks. Expand the balloon to about the size of your head. Measure the new distance from home to each point and record the results. Be careful not to compress or dent the balloon while making the measurement. Calculate the distance each point moved by subtracting its first recorded distance from home from the second recorded distance. Have someone check the calculations. Record the results on the data sheet. Now divide the distance each point traveled by the time it took, or 1 epoch, to get the expansion rate. This is the rate of expansion of your balloon. Record the results for each point on the data sheet. Now you're ready to plot your data. Using the data from the universe data sheet, plot the points, distance traveled, expansion rate. Team members should verify that the points are plotted correctly on the graph.
So, what conclusions can you make from this lesson?
Well, for one, our graph looks just like the Hubble data graph. We created a pretty good model for the expansion of space. Our data showed a linear pattern like the Hubble data.
That's great! Any other thoughts about this lesson?
We learned how to use a metric system. Science is fun. How the universe expands.
Way to go, guys! You did a great job. Hey, teachers, check out our NASA Connect website and download the lesson guide from this program. In it, you'll find this student activity, data analysis questions, extension activities, and tons more.